All right, we're going to do a couple problems here on page 224. We're going to start with number 15. Obviously, it looks like a two-column proof here, but this one in particular is hard because they actually want you to prove two things. So we're going to do two proofs. We're going to first prove why certain lines are perpendicular, and then we also are going to prove that a line is bisected. So if I look at this yellow proof here in yellow, we're going to try to figure out why these two lines are perpendicular. Well, somewhere along the way, in order for lines to be perpendicular, there has to be a right angle. So we're going to try to figure out why this is a right angle. And then in the pink here, it says BD bisects AC. We're going to have to, if you're going to bisect this pink line, this line here bisects AC, this left must equal this right. So eventually we want to prove that this left is equal to this right. Okay? So let's now go back to the start, which I've already written down here, and BA is congruent to BC. That's given, so let's just tick mark that up. BA tick, BC tick. That's obviously a side. BD bisects angle ABC. So we are going to, this guy bisects this green angle, ABC. All right, so that's not an angle or a side, but we're going to use that information. Because this green angle at the top got bisected, we are going to say that this tip angle on the left is equal to the tip angle on the right. So ABD, this guy here, I'll put a tick mark there, is equal to angle CBD, this angle here to the right. And the reason why I can say this, it's not in the given, but the given does say that the green angle got bisected. So we're going to say definition of an angle bisector. The previous step mentioned that this is an angle bisector. Well, what does that mean? The two angles are equal. So now we've got an angle. We're going to need one more piece to the puzzle here, and then we're going to say the triangles are congruent. We're going to say side length BD down the middle is equal to BD. Of course, that's reflexive property, and that will give us tick tick. That gives us the side. Now we are going to mention that the two triangles are congruent. We're going to say triangle ABD on the left is congruent to triangle CBD on the right, and we're going to say side angle side, side angle side. All right, from there, we're now going to focus in. We've got two congruent triangles. We're going to focus in on the angles here. I want to put a angle 1 and angle 2 here. And I'm going to focus in on trying to solve for this first one in pink here. Let's go with this. This is going to be a little bit of a long process. I'm going to say angle 1 is equal to angle 2 because those are corresponding parts. I just proved that the triangles are congruent within congruent triangles, and they are congruent themselves. So angle 1 and angle 2 are congruent. But not only that, I want to say angle 1 and angle 2 are right angles. And this one's going to be hard to explain, but basically, if two angles are congruent and two angles form a straight line, then they must be 90 degrees. And there really is no formula for this, so I'm just literally going to spell out what I just said. If two angles are both congruent, which they are, because we said in step 5 that they are congruent, and supplementary, they both form a straight 180 degree line, then the angles are 90 degrees. Now that's pretty wordy, and we've never used that before, but that essentially is just spelling out what's going on. We know that they were equal angles. We know they made a straight line, so the only way you can make a straight line 180 degrees if it's 90 and 90. Now we're going to go to the first proof. Why is BD perpendicular to AC? And we're going to go with the mere fact that I have 90 degrees means that lines are perpendicular. So I'm going to say definition of perpendicular lines. If you really need to spell it out, because the angles are 90 degrees, that makes the lines perpendicular. Okay? And now I'm going to go and try to solve the pink guy here. The pink basically says why is BD bisects this bottom line AC. Well, I need to say that AD is equal to CD. AD is equal to CD, and the reason why is, again, those are corresponding parts, and I'm going to go tick, 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 tick. Those are corresponding parts within the congruent triangle, step 4. Therefore, they are congruent. Now I'm going to go with the final proof. BD bisects AC. We can say the line that's going straight up and down bisects the bottom segment because this is going to be the definition of a bisector. Definition of a, you can write segment bisector, or I'm just going to say bisector. Because step 8 said left and right are equal, that means this line is the bisector. This guy is the line that just chopped AC in half. So definition of a bisector. Very difficult proof. In fact, it's really 2 proofs. One in yellow, one in pink. All right, I'm going to do problem number 16 here, a proof. Let's see what they want us to do. Prove that PA is congruent to PB. So we're going to try to prove that those 2 yellow side lengths are equal. What I want to do first is, if I can prove this left triangle is equal to the right triangle, then I can go CPCTC. So let's go with the given. It's already written, but what does it say? It says this line L is perpendicular to AB. This line L bisects AC. I don't think it's AC, it's AB. This should be AB. That's a really bad B. But it bisects this line here. So with that first step, although it's in the given, there's no congruent angles or congruent sides. So let's give ourselves some congruent sides. Because we bisected this bottom side, this left is equal to this right. AC is equal to BC. And that's the definition of a bisector. We mentioned that there's a bisector. And so now we know AC, tick on the left, is equal to tick on the right. Okay? That's a side. We also know that this line coming straight up and down from the given is perpendicular. So I'm going to put a 1 and a 2 here. And basically I'm going to say, I'm going to do this in 2 steps. I'm going to first mention that angle 1 and angle 2 are right angles. And the reason why they're right angles is because you have perpendicular lines. I'm going to say definition of perpendicular lines. By definition, if 2 lines are perpendicular like the pens, you create 90-degree right angles. Okay, so we now know that these are right angles, but we never said that they were equal. So let's just flat out say that angle 1 is equal to angle 2 here in step 4. Angle 1 is equal to angle 2. And because they're right angles, all right angles are congruent. Obviously 90 degrees is equal to 90 degrees. Now we flat out said equal. So that's an angle. So we got an angle, or excuse me, a side, an angle, and we need one more side or angle. In step 5, we're going to say PC down the middle is equal to PC down the middle. And that is, of course, the reflexive property. Reflexive property. And tick, tick. Now I'm going to, I have enough information to prove my triangles are equal, so I'm going to say PAC, triangle PAC on the left, is congruent to triangle PBC. And we're going to say side, angle, side. We've got a side, we've got a 90-degree angle, and another side, a side, 90-degree, and another side. And then finally, we're going to go to our proof. What are we trying to prove? We're trying to prove that side length in yellow, PA, is equal to PB. And those yellow parts, they happen to be corresponding parts within the congruent triangles. Therefore, they are congruent themselves. Step 7.